Hi folks, and welcome back to Math with Captain Rod. Making this video here to demonstrate how to find the max or min values of parabolic functions, and I'm going to go through two examples in this video here. We're going to go through this one and this one. So for starters, let's talk about how to know whether or not you're looking at a max or a min. The number in front of the x squared term, when that's positive, it opens up. When it's negative, it opens down. So this parabola opens down. It's got to look something like this. So the vertex here is the highest point on the parabola, so that would represent a maximum for that parabola. This one, the a value is positive. That means this parabola opens up and looks something like this. So the vertex here is the lowest point. It's going to represent a minimum for that parabola. So one of these is a max, one's a min. Now, what we want to do to find the min or max value is we want to find the vertex. So what we want to do is to write them in this form: y equals a times x minus h squared plus k. Then the vertex will be the point hk, and we'll know the min or max value. So let's do that. We're going to take this animal here, and again, this process to make this look like this is called completing the square. You want this to be a 1 here, so a good first step, multiply everything by -1. Very carefully. That's going to make that minus 10x, and that's going to make that plus 3. You notice I left myself a little space here. If you've seen some of these examples, you know that typically what happens is you end up having to add something here to make this a perfect square. Next line. All right, so we want to make this equal to x minus something squared, minus because I can see that's a negative number. And the big question is, what do you put here? And you always look here. Take this value, cut it in half. That will be a 5. And I've already, talked about the minus sign. But remember how FOIL works. That very last term, if you were to multiply this back out, would be 25, and we don't have a 25 here. So what we'll do is we'll just supply it, 25. Now these are exactly equal. But if I add 25 here, I have to take that into account either by adding 25 to the left or by subtracting 25 over on the right. I'll go ahead and do that. Okay, so now these are exactly equal, these are exactly equal, and 3 minus 25 is negative 22. So we'll just simplify that here. This is now minus 22. All right. Now we take the minus sign, put it back over on the right. All right, so what do we know about this parabola, right? We already knew this, but this is telling us it opens down. The vertex is at the point 5, 22. Remember, we're comparing x minus 5 to x minus h, so h is 5. Or think about it like this. This x minus 5 is this minus 5 translates the graph to the right 5 units. That's why that vertex is at a coordinate of 5 plus 5. And then our k is 22. So we know this parabola does something like this. The vertex is at the point 5, 22. This is the maximum value. So I don't know, we could say it's something like y max is equal to 22. Just for kicks, let's talk domain and range of this animal. Domain is all real numbers. The range is y has to be less than or equal to 22. So let's talk about this one. Same deal here. We need to start with a 1. So I would start this by dividing everything by 3. So the new line, or next line, y over 3 equals x squared plus 1/3 x minus 1/3. You typically leave yourself some space here, so let's move that over. This one's going to have some fractions. That makes them a little more work, but still not horrible. All right, so we have y over 3 equals. Now the idea is we want to write this as x plus something, the quantity squared. And the million-dollar question is, what is the something? You look right here. You take this value, you cut it in half. If you take 1/3, cut it in half, you have 1 over 6. Okay, but next step, if you were to multiply this out, that very last product is 1/36. So we take that, and we're going to add that right there, 1 over 36. And to maintain equality, subtract 1 over 36 on the right. All right, so now when we kind of look at these lines, these are equal, these are equal, and let's simplify this here. Common denominator here is 36, so let's see, this would have to be multiplied by, what would that be, 12? So I'll go ahead and put minus 12 over 36 minus 1 over 36. Let me just double check that here. It's early in the morning and I've not had a ton of coffee yet. Yeah, that looks right. Okay. One more line here. So y over 3 equals x plus 1 over 6 squared. Okay, so negative 12 over 36 minus 1 over 36 is what? Minus 13 over 36. Put the 3 back where it belongs. Let's see, that's going to be minus 39 over 36. These are both divisible by 3. I'm not going to bother. I'm just going to leave it alone. This parabola we know opens up. If I did, just a little mini sketch, it looks something like this. The vertex is at the point minus 1 over 36, 39 over 36. Right, and I'm getting the minus 6 from comparing x plus 1/6 to x minus h. H must be negative 1/6. And there's my, oops, I missed the minus sign. K is minus 39 over 36. This is the lowest point on the graph, so this is a minimum value of y, so let's call it y min is equal to minus 39 over 36. Please simplify at your convenience. Range of this function, while we're at it, all the y values are larger than this, so the range of this function is y must be greater than or equal to minus 39 over 36. So again, I'm just making this video here to demonstrate how to find max or min values of a parabola. It boils down to finding the vertex. And then whenever this a value is positive, it means the parabola opens up and the vertex location gives you the minimum value. When the k value is negative, like this one, the parabola must open down and the vertex gives you a maximum value. So I hope that this video helps with these concepts. Have a great day.